Hi, welcome to this lesson where we are going to work on counting significant figures. This lesson in itself can't really stand alone. The reason we have to count significant figures comes from when we take measurements and then go and manipulate them. So let's just kind of backtrack a little bit. If you were to take the numbers 1.2 and multiply that by 3.6, each of these measurements originally has two digits, only one behind the decimal. It's measuring to the tenths place, which really means that our tool can measure to the ones place, and then we have to estimate how far, let's just say it's volume. We have to estimate how far the water level, or the solution rather, is measuring between our graduations. So it's at least one. The reader of this measurement is assuming that it's 1.2 as opposed to 1.3 or 1.1. And then same here, the measurement obviously is 3 something. It's a little over half, so this person has measured it at 3.6 milliliters. Let's just say that. When we go and let's say we need to multiply these two numbers for whatever reason, the resulting answer is 4.32. And this is where SigFigs comes in. This tool here measures to the ones place, and then this is the estimated digit, right? When we manipulate the numbers, it looks like this 3 is the measured number, and then this 2 is that estimated digit. If that's a little unclear to you, there's a link in the description on how to read measurements. So significant figures, the goal of it is to fix this problem where all of a sudden it looks like our tool is better than it started. And the first part of that is being able to count the number of significant figures. And then the next video that I publish here will be a video on how to do math with significant figures, which is really like the two things have to go together. When it comes to teaching them, I like to split them up, but in totality, the two absolutely go together. We're not counting significant figures for no reason. We count significant figures because we need that first skill before moving on to the next skill. So when it comes to counting those significant figures, there are some rules, okay? So that first rule is that any number that is not 0 counts as a significant figure every single time. And that is because they are giving real measurable value to a measurement. And 0 is the only number that might be significant or might not be significant. And that's going to depend on a few factors. So number 1, we have trailing zeros, like in 1,000, or these 2 zeros after this 2 here. Those could be, well, they are trailing zeros. Trailing zeros only count if there is a decimal present in the number. Then we have leading zeros, and leading zeros like these zeros here or these right here, those will only count if there is, leading zeros will never count. Then, I don't have an example here, which is kind of silly, but let's say I have a sandwiched 0. I don't know what the technical term is for a 0 between two non-zero numbers. Sandwiched zeros are always going to count. And that's a lot of rules. So there is a trick that can help with, instead of keeping all of these rules straight, can help you to figure it out. And there are no exceptions to this rule. It's going to work every single time, which is fantastic because we don't like rules that have exceptions. So if you picture a map of America, on this side is the Atlantic Ocean, and on this side is the Pacific Ocean. We're going to use P and A to represent present and absent in reference to the decimal. In the number 12,345, we're going to pop that inside of the map of America, and because the decimal is absent, meaning it's not written, we are going to approach this number from the Atlantic side. We will come to the first non-zero number and count everything that comes after it in that same direction. So 5, 4, 3, 2, and 1 all count because they are all non-zero numbers. But they also count because they come after the first non-zero number in the Atlantic direction. So This will have 5 sig figs. I'm just going to abbreviate that as SF for the purposes of space. So that number has 5 significant figures. None of them are 0, so they will all count. 1,000 with no decimal has the absent decimal. It's not written. So we're going to approach this number from, again, the Atlantic side. And we're going to skip over those zeros because we are looking for the first non-zero number in this direction. And that's going to be the 1. And there is nothing that comes after it in that same direction. So 1,000 with no decimal has only 1 significant figure. Up next is 500 with a decimal. So because the decimal is present, it's written, we are going to approach from the Pacific side of the number. And the first non-zero number that I hit is that 5. So I'm going to count the 5 and everything that comes after it, meaning that I have 3 significant figures in this measurement. So the difference between 1,000 and 500 is the decimal. In this case, only the 1 will count because there's no decimal written, but in this case, all of the digits will count because there is a decimal. 0.00203, the decimal is present. I am going to approach from the Pacific side of the number, and I'm going to skip over all of those zeros because I'm looking for the first non-zero number. I'm going to count the 2 and everything that comes after it. So in this case, I have leading zeros that don't count. I have a sandwich 0 that does count, and that is all. So in this case, I have 3 significant figures. The next one, again, the decimal is present, so I will approach from the Pacific side of the number. I'm going to skip over my leading zeros because I'm looking for the first non-zero number, which is 2. I will count the 2 and everything that comes after it, approaching from that Pacific direction. So that would give me 3 significant figures on that measurement. All right, I'm going to give you an opportunity to pause the video if you choose, see if you can try these. This will be the last set. Okay, in 6,547, all of those are non-zeros, so that would be 4 significant figures. In number 7, scientific notation is probably a new one. For scientific notation, when it comes to counting significant figures, you are only going to look at the coefficient and ignore the times 10 to the whatever, because that times 10 to the whatever just represents zeros. And the zeros that are locked into scientific notation will not be significant. So you're just going to look at that front piece. The fact that those zeros are locked into scientific notation tells us that they're not significant when it comes to doing calculations with the measurement. Obviously, 1.2 is very different from 120,000. So you just look at that coefficient when it comes to scientific notation and counting sig figs. So 1.2 would have 2 sig figs. 6.500 decimal is present. Count the 6 and everything that comes after it. That would give us 4 significant figures. In number 9, 0.23500, the first non-zero number from the Pacific side is the 2. So we count the 2 and everything that comes after it, giving us 5 significant figures. And then finally, we have 120, which decimal is absent. So we have to approach from the Atlantic side, skip over the 0, count the 2 and the 1. That gives us 2 sig figs, and that is all. Okay, I hope that counting significant figures has gotten easier. If not, go back, check out the lesson where I actually taught how to count sig figs. That could help a little bit, and maybe you just have to get deeper into it. There are some topics like that. So the next video published on this channel will be math with significant figures, which maybe could help it to click. So stay tuned for that. If you have any questions, of course, leave them in the comment section below the video. Subscribe so you don't miss our next practice session, and I'll see you there. Bye.